Maxwell's equations, integral and differential forms. Maxwell formulated four basic equations, both in electricity and magnetism, relating the two in integral and differential forms. The integral forms of the equations are this. Integral over a closed surface E dot ds is q by epsilon naught. That is, wherever there is a charge, there is an electric field E. And the relation goes this way. Over the surface, closed surface, ds will give you the area of the surface. Second one. Integral over a closed surface, B dot ds is 0. B is strength of magnetic field or magnetic flux density. So over a closed surface, magnetic flux density is 0, because we know that magnetic lines of force, they start at the north pole and end at the south pole outside. But inside they go from south to north, that is, they are closed lines, and hence the magnetic flux density over the entire surface is always 0. The third one, integral E dot dl, that is over a line, a particular part of a conductor, is minus d phi b by dt, that is rate of change of flux. Phi b is rate of change of flux density, magnetic flux density. This is electric field, relation between the two, the third law. Fourth law, integral B dot dl is mu 0 into J plus epsilon naught dou E by dou T. J is strength of the electric field, current density, strength of current density, strength of the electric field, strength of the magnetic field. These are the four laws in the integral form, very, very important, which relate between electricity and magnetism. Now, the same four laws in differential form are stated in this way. Div A, that is divergence, del dot. Div A is rho by epsilon naught. It can be written del dot D equal to rho, where D is displacement current, rho is charge density. Second law, div B is equal to 0, or del dot B is 0. Third law, curl E is minus dou B by dt, or we know curl is del cross E. Del cross E is minus dou B by dou T, relation between E and B. E is strength of electric field, B is strength of magnetic field. Fourth, curl B equal to mu 0 into J plus epsilon naught dou E by dou T. B is strength of magnetic field, strength of electric field. Current density, epsilon naught permittivity of free space. So these are the four laws in integral form, Maxwell's four laws. These are the four laws in differential form. Now we can derive from the integral form to the differential form, the derivation. Before that, let's once again see what is D, electric flux density or displacement current. Capital E, strength of electric field or electric field intensity. Capital B, magnetic flux density or strength of magnetic field. It is given by B equal to mu H. What is H? Magnetic field intensity. Mu, permeability of the medium. It can be mu 0 or mu R. This mu is permeability of the medium. It is a product of permeability of free space into relative permeability of the medium. Mu 0 into mu r. Sigma, conductivity of the medium. Rho, volume charge density. V, volume. Jc, conduction current density. J, conventional current density. So once again, Maxwell's equations in integral form, all integrals on the left hand side, Maxwell's equations in the differential form. Now we will derive the first equation from integral form to differential form. Similarly, second from here to here, and so on. So now the derivation. Derivation of Maxwell's equation. First equation. Now the first equation in the integral form is integral E dot ds is q by epsilon naught. Okay. If we take dv as a small volume and charge density to be rho, this q can be written as integral over the entire volume rho dv. Therefore, integral E ds will be 1 by epsilon naught. In place of q, write this rho dv. Now cross multiply, take epsilon naught here, you will have epsilon naught E dot ds is equal to rho dv. Now epsilon naught E is equal to d. Therefore this can be replaced by d. So d ds is equal to rho dv. Now you apply divergence theorem, Gauss divergence theorem. Surface area is equal to volume integral. So this is Gauss theorem. Integral a ds is equal to del dot a dv. In place of a, put d. So integral d dot ds is equal to volume integral of del dot d dv. Now compare the two. This right hand side is equal to this right hand side. After you compare, cancel dv. Del dot d is equal to rho, or del dot e if you want, it is rho by epsilon naught because e is d by epsilon naught. Substituting that value. Del dot d can also be written as div dot e. This div means dou ex by dou x plus dou ey by dou y plus dou ez by dou z. This is rho by epsilon naught. Rho by epsilon naught. So this div e is equal to rho by epsilon naught. We started with this integral E dot d and we got div dot e. If you come back to the first page, integral E dot ds, this is the integral form, differential form. Here we started with the integral form, we got the differential form. So this is derivation of Maxwell's first equation.